resultant in 3 dimensions. In the previous section, we defined the resultant as the simplest force combination which can replace a given system of forces without altering the external effect on the rigid body on which the force acts. We found the magnitude and direction of resultant force for the two-dimensional force system by a vector summation, and we located the line of action of the resultant force by applying the principle of moments. This same principle can be extended to the 3 dimension. In the previous article, we showed that a force could be moved to a parallel position by adding a corresponding couple. Thus, for the system of forces F1, F2, F3, for example, as shown in this picture, F1, F2, F3 this case F1, F2, F3. We can replace to the F1, F2, F3 for on point O. We have F1 and M1 force couple F2 and M2 also force couple system F3 and M3 force couple, and we can write the resultant of this replacement R equals to sigma F and M equals to sigma M, which is equals to sigma R cross F. The couple vectors are shown in this picture, but because they are free vector, they may be represented in parallel positions. The magnitude of the resultant and their complements can be written as this description: sigma Fx, Fy, Fz, and Mx. The point oscillated as the point of concurrency for the forces is arbitrary, and the magnitude of and direction of F depend on the particular point O in this picture. Point O because O is arbitrary and the direction of M also be differ due to the various point O that we can choose. The magnitude and direction of R, however, are the same no matter which point is selected. In general, any system of forces may be replaced by its resultant force R and the resultant couple M. In dynamics, we usually select the mass center as the reference point. The change in the linear motion of the body is determined by the resultant force, and the change in the angular motion of the body is determined by the resultant couple. In the static, the body is in complete equilibrium when the resultant force R is 0 and the resultant couple M is also 0. Thus, the determination of the resultant is essential in both statics and dynamics. We now examine the resultants for several species force systems in the next video.